So I'm going to talk about something I've been recently working on. And yeah, so as I said, it's the last talk of the day. If you guys want to sleep, please don't sleep, or at least, at the very least, please don't snore. So I'm Simone. I'm a developer from Xebia. Xebia is a company who works for, does client work for a number of widely used apps here in Paris. But before Paris, I was living in Milan, and I was a young and inexperienced developer. And at the time, I was doing apps for the Microsoft Surface. So the Microsoft Surface at the time was different. It was like a table, a coffee table, with multi-touch gestures. And you could create apps on that, and it was super cool. And actually, my life at the time was super easy and beautiful. But two things arrived that changed my life forever, I'd say. The first thing is that I met this guy, a salesman. So my agency, as all the agencies in the world, has a salesman, or had a salesman. You know, those men capable of always being right and winning any possible debate with a never-ending monologue in which your only way out was to say yes. And that was my salesman. And the second thing changed my life forever was a new revolutionary product that came on the market at the time. It was the iPad, and it was 2010. So the iPad came out, and the salesman went to my desk and told me, all right, I have a customer that wants to do an iPad app, but there is a catch. Nobody knows how to do iPad apps because nobody has an iPad. And you know, you're doing multi-touch apps on that Surface. So of course, you know, Surface has multi-touch, iPad has multi-touch. So, you know, a Surface app is like an iPad app, isn't it? All right, I was very young and inexperienced, as I said. So I accepted the challenge, and I became an iOS developer. And my life was quite good once again. Until a third thing arrived that changed my life once again. This thing. So, this is the Motorola Xoom. I assume somebody of you owned one of those things. So it's the first real Android tablet with Android 3.0. And I guess you know how the story goes. So my salesman once again comes to my desk and tells me, okay, I have this super customer that wants to do an iPad and Android app at the same time, you know, those fat client logic apps that you want to do at least once in your life. And, you know, we don't have any experience on that, but, you know, an iPad is a tablet, a Xoom is a tablet. So, you know, an iPad app is like a Xoom app. Right. Wrong. That's wrong, actually. So I actually accepted the challenge because I was inexperienced. I guess I was stupid as well. But what actually happened is that, yeah, I started doing something, but it became a nightmare. So the project didn't go very well, as you may guess. So I realized at the time that I had two fears. The first one was the fear for cross-platform apps. And the second one was a fear for salesmen. You know, years later, I moved to Paris, and I kept on doing what I liked the most, which is iOS apps. And I learned Swift, which is a language I really like. And yeah, my life was good once again. And at the same time, many cross-platform stuff came out, like React Native, NativeScript, Flutter, it's very popular today, Xamarin, and I guess, guys, you know WinDev, which is, I guess, the best cross-platform framework here. And you know, my feeling for all this thing is a bit biased, I'd say. I can say I like them, but at the same time, you know, those nights in which you cannot sleep and start wondering about the meaning of life, or like questions like, will I ever be a good father, or will they ever stop planning Star Wars sequels? Well, one of those nights I started thinking about an important question. Should I really keep on ignoring cross-platform apps? Is it really a good choice for me? So in one of those nights, I dreamt of a hero capable of saving me from my fears. I dreamt of Konan. Konan. Konan stands for Kotlin Native Backend. That's true, actually. I know. And of course, is the compiler for the Kotlin Native variant of Kotlin, which brings us to Kotlin. So, who knows Kotlin here in the room? You know, the stupid questions. Wow, unbelievable. Who's using Kotlin today, really? Almost everybody. Wow, I'm impressed. So Kotlin runs in the JVM. 20% of apps use Kotlin today, I guess more. And this figure should reach 50% by the end of this year. It runs server-side. It can be transpiled to JavaScript thanks to Kotlin.js. And it's a language that has many similarities, I'd say, with Swift. Like it is object-oriented with bits of functional programming. It is statically typed. It has optionals. It has mod casting, which Swift doesn't have. It has function extensions, lambda inlines, data classes. So there's one thing that can be said about Kotlin, is that if I compare that to Swift, Kotlin is a bit like Swift. And there is even a website for that by Gauthier, one old friend of mine. And I'd say my salesman will be happy to hear that. So how it works. I'm going to be serious now, I'm sorry. So a traditional Kotlin compiler brings code and it transforms that to bytecode, thanks to the JVM compiler. The Kotlin native compiler is a bit different, so there is two steps here. Of course, you start from code, Kotlin code, and this code is transformed into IR, which is an intermediate representation, which can be called sometimes also bitcode. This IR is given as input to the second layer of compilation, which is handled by LLVM. So LLVM is an open source project that was created by Chris Lattner, the guy here on the right, not the guy on the left. The guy on the right who actually worked at Apple, he's the guy who created Swift and the guy who created all the compilers that today iOS developers use every day. So it's the same architecture. And we can even say that a Kotlin native compiler is like a Swift compiler. How cool is that? So thanks to this, we have a number of supported targets, which are Android native, Linux, macOS, iOS, and so on. And it's interoperable with any C, C++, and Objective-C library, as long as they suppose an .h header. And if we talk about Objective-C libraries, of course, well, we are talking as well about iOS SDK libraries, which are Objective-C libraries mainly. So, I guess you guys have a question. I hope so. Can I write an answer is yes. There's even a demo for that, a demo which was built by the Kotlin team, of course, and which works very well. It's a demo with the native views. Everything is written in Kotlin. But there is another question. Can I write a complete cross-platform app in Kotlin? Well, the answer is no. And so, yeah, my life can be happy. But there's something we can do. We can build iOS frameworks. So since Kotlin Native 0.5, so since December 2017, we can now create iOS frameworks with Kotlin native. And so we can finally share a cross-platform module between Android and iOS, as the GIF shows. So let's try this out. My goal was to create an app to present myself, to rehearse my slides. So these slides are written actually in Markdown, thanks to a program which is called Dexet. And it's a variant of Markdown that is quite different from the traditional Markdown, so we need a special parser. So I want to read my slides on my mobile, and so I want to create viewer apps that can share some logic. Not all the logic, because I don't like that. So I have still a specific logic for iOS, which is coded in Swift, specific logic for Android, specific view logic for Android, which is coded in Kotlin, and a shared parsing library, which is developed in Kotlin, but compiled twice. So the same code is compiled twice. Once for iOS, and we'll build a framework, and once for Android, and will be a .aar. To do this, there is a number of solutions, but the cleanest setup is to use Multiplatform API, which is available since Kotlin 1.2 and Kotlin Native 0.6. We can share code between JVM, Kotlin JavaScript, Kotlin Native, with a DSL that works on Kotlin and Gradle. This setup is as follows. So we have a common project that contains all our shared code. In case we are targeting just the Android part, we will have a second project, which is the Kotlin JVM project, which will include the common part and then compile everything to classes. In case we want to do an iOS framework, well, we do the opposite. So we create a project for the Kotlin native thing, and we import the common project, and we'll have as output a bit code. So the project setup is as follows. This is a tree, a file tree. So we have a build.gradle, and then we have 3 subprojects. One subproject for the common part, we just call side parser, and 2 others, one for Android and one for iOS. Of course, we use Gradle, and I'll show you the Gradle files just now. So this is the Gradle file for the common part. I don't think it's really readable, but you can grab the slides after the talk. And just for you to know, we apply the Kotlin Multiplatform plugin, which is available since, I guess, 1 month or so. And then we apply the Kotlin Multiplatform standard library. For Android, same thing. We apply the Kotlin Multiplatform plugin for Android. We do all of our Android configuration, and then we say that this project, the Android project, is expected by, so it should include the common project, which in our case is called side parser. On iOS, it's the same stuff. So we apply the Konan plugin. We do our iOS specific configuration, and then we import once again the common project. When we run Gradle tasks, we got our 200 lines of tasks, and we got one more line which is specific to iOS, which says compile Konan Kotlin slide parser. It's a bit long, but it's my example. And if we run this line, the output is this one. So it's 2 files. The first file is the only one that really we care about, is a folder which is called framework. So this is just a normal, totally 100% compatible with Xcode framework. It's totally perfect framework that we will be able to include on our iOS project. And actually, we can say that a Kotlin framework is like a Swift framework, except that it's just a framework. So a framework is just a framework. So I guess my salesman would be happy anyway, but I don't know why. Let's talk about the IDE. So we can do all that with Sublime, and it's what I did when there was no IDE available at the time. But now we can choose between 2 or 3 IDEs. We can use IntelliJ or Android Studio, but they won't work for the Kotlin native part. They can just read your Kotlin code. You have syntax highlighting, but you don't get auto-completion. To get auto-completion, you have to install another IDE, which is called AppCode. It's the IDE for iOS developers. And since last week, there is one plugin that supports Kotlin native. So the situation is still a bit sub-perfect, I'd say. As for testing, testing is supported out of the box with Kotlin Multiplatform. It works quite well. You have IDE support. You can write tests as you would normally do. And there is just a catch. Kotlin native requires an additional configuration. I won't detail the configuration here, it's a bit long, but I wrote a post about that if you want to know more about this. So I hope you're still alive, and we're going to go deeper. Just a question, how many of you are iOS developers as well? Wow. Isn't that supposed to be called Android makers? All right. So let's talk about Objective-C a bit. So we are going to compare Objective-C headers. So as I showed you, there is one framework file which is produced by Kotlin. And there is inside this framework file, there is a .h file, which is C header, which is generated by the Kotlin native compiler. So this code is not supposed to be readable anyway, but there is a sum up. So if you write like Boolean in Kotlin, you will get a bool in Objective-C. That's quite nice. And that's the same for floats, doubles, integers, more or less. They get mapped to integer 32. Strings are bridged, which is super nice. So you can work with strings between Kotlin, Objective-C, and Swift. Lists are converted as you would expect. So generic list, so a list of a string, for example, gets converted to an AS array of strings or to an array of strings in Swift. It's not the same thing for arrays, or Kotlin arrays of strings. They are not actually recognized, so they are mapped to standard library arrays at the moment. One super nice thing is that optionals work. So I believe optionals is one of the best features of Kotlin and Swift languages. And in the Kotlin parser, in the Kotlin compiler, this is respected. So if you have an integer which is optional, but it gets converted to a number, to an optional number. And it's the same thing for strings and for any optional class. As you would expect, but actually I was surprised to see that, interfaces get mapped to protocol as you would expect. Classes are mapped to classes. Data classes are mapped to classes because they actually behave like a class. So it's not surprising here. Enums are not mappable to Objective-C because they are totally different stuff. And open and public modifiers get converted to subclassable stuff. And that's because Objective-C can tell the difference between public and open. So for Objective-C, everything is just open. Another thing I was really surprised with is debugging. So debugging is supported. The compiler produces a DSIM file, which is the standard file for debugging in the LLVM world. And so this allows Xcode to be used for debugging. So if you create a breakpoint via the LLDB, you get even auto-completion. So here I'm just creating a breakpoint for a kfun, so a Kotlin function. And as soon as I type kfun colon, I have this menu that shows an auto-completion. And this is my favorite part. So here we put a breakpoint the application paused on a breakpoint, and we got the stack trace, and we got here, as you can see, this is not Swift code, this is Kotlin code, and this is Xcode. So Xcode is capable of reading your Kotlin code as long as you have linked the DSIM file. So, wow, Xcode is like app code now. Well, there are some features which work. For example, breakpoints, the stack trace, stepping. But there are something which doesn't work, which is value inspection of object. And it's quite a massive thing, but the team is working on that. Let's talk about memory management. So since we work on mobile devices, on devices which are not supposed to eat up all your memory, as Slack does, we have an ARC-based memory model. So ARC is automatic reference counting, which is the same strategy than it's used in Swift or in Objective-C. But there is a GC, so a garbage collection, on top of it, which performs garbage collection at runtime. So garbage collection of retained counts is performed periodically, and the advantage here is that you don't have to use weak or unknown references, and every retained count element is actually handled by the Kotlin runtime, which is kind of cool. And as for exceptions, here there are some positive and negative things. So since all exceptions are unchecked in Kotlin, as far as I know, and throws is not supported in Kotlin native, we have some issues here. So we cannot bridge Kotlin exceptions to Swift errors, and if we forget to handle an exception, the app will crash, and we won't have any way of handling the exception in Swift from Swift to prevent from a crash that happened in the Kotlin layer. So, boom. There is also some efforts which are being done on concurrency. So Kotlin native supports worker type of concurrency, which is not the same workers as in JavaScript, unfortunately, and coroutines. So it's almost like Kotlin JVM, but there is a catch here, once again. It's not the same coroutines than in JVM, because we lack, at least in Kotlin native, the Kotlin X extension for coroutines. So it's not at all developer friendly. But yeah, let's see what my app does. So here's some Kotlin code I wrote for my app. Of course, my app is a bit longer than that. So we have this code, we compile it in with Kotlin native, we get our framework, and then we drag and drop the framework on Xcode, and then we can start doing this. So this is Swift code, and we just to import Kotlin slide parser, which is the name of our library, and here we are using our APIs, which are written in Kotlin, as if they were written in Swift or Objective-C. And what's cool is that you wouldn't even guess that this app or this library is not coded in Objective-C. So as you can see, or I don't know if you can see from there, but when you read the slides, you know, it just looked like Objective-C code, and that's super nice. So this is the Android part. So once we created our AAR, we import that in an Android project, and so we can use our library directly from Android. And if you don't believe me, here's a demo. It's super beautiful, I know. Yeah, you know, my designer was on holidays during the demo, so, right. And so, our salesman will say that this thing is perfect, right? Well, of course, there are some limitations, because Kotlin native is still a technology preview. And so there are things which are not working yet. So compilation time, let's skip this. It's long. We know it. It's not a real issue. I didn't even benchmark that because it's not fair. It's a technology preview. I'm not joking. I'm that funny that I know I'm making you laugh even when I'm not supposed to. Anyway, thank you. And so it's not 100% compatible with iOS bitcode. So this will have will cause some issues when you try to select your settings when you run the app, and most of all when you try to submit the app to the App Store. You have to know this. Some everyday functions are not available. I told you about the throws function, which is not throw annotation, sorry, which is not available. Many functions that came from the Java world are not here in Kotlin native, like file management. And there is almost no Kotlin extension available today. We cannot inspect objects in the debugger, as I told you before. And, well, this is obvious, but there is no documentation for this. So all the steps I showed you, well, it's just a matter of digging sometimes in the Kotlin native compiler, or talking with the Slack team, or figuring out things. There is some possible pain points. So the garbage collection thing looks like a super nice thing. We still have to understand if it's a weakness or a strength, because I don't have a large benchmark or a massive app that uses Kotlin native. So let's hope for the best here. And there will be some platform difference to overcome. For example, multithreading, which is not supposed to work the same way in Kotlin JavaScript or in Kotlin native. And as you saw before, there are some types that poorly translate to Objective-C, most notably generics. So Objective-C doesn't support generics apart from array and dictionaries or maps. And so you cannot use generics basically in Objective-C. We have to see, we'll see if the team will provide a direct interoperability between Swift and Kotlin, because Swift supports generics. But still, the future is now. So the team is working on feature parity between different Kotlin dialects. Kotlin dialects being Kotlin JVM, Kotlin JavaScript, and Kotlin native. And there are new common extensions that will be available, I guess, soon, like coroutines or serialization. The second one is quite cool, so you can actually start creating modules that make some sense. For example, all the serialization part can just be done once for iOS and Android. And better debugging, of course, which is a major pain point today. And I'm not working for JetBrains, but still, I guess, if I understand their business model, they will certainly be doing a new IDE that will be mutual for Android and iOS, and we will leverage all the Kotlin multi-platform stuff. So if I didn't bore you enough, you can read more about this. There is a great talk about the team at Kickstarter that shows how we can have synergies between iOS and Android teams when they are using Kotlin and Swift. The Kotlin blog is a good way to stay in touch and to get informed about what happens in the Kotlin world. There is a video by Andrei Bereslav at the last Kotlin Conf that shows you more or less the same thing I showed you today. And if you want to read more, there is the blog of Xebia and my personal blog with this kind of documentations and articles on which give you more details about testing and multi-platform. And of course, the Kotlin Slack is a precious resource. People there are really, really helpful. They reply you in 2 or 3 hours, and you often get the chance to talk with the Kotlin core team programmers, so they know how things work and they really help you. So that's almost finished. We are summing up. So Kotlin multi-platform and Kotlin native, still technology preview, but it's a nice approach that encourages modularity. and of course give you a paradigm that feels familiar to all mobile developers. So it's a new approach to cross-platform, and hopefully an approach that will help me defeat my fears. So thank you very much. That's all for today, and well.